guess what we're going to do?
Talk about that weird equation you just wrote?
Yeah, Q equals MCAT, MC delta T. All right, so we're going to actually do some calculations, do a little bit of math. It's okay. You're going to be fine. Don't worry, I promise.
Okay.
All right, so let's talk about what each individual one of those things is. This is a whole specific heat. This is all about heat, by the way, in case you didn't know.
Specific heat.
Specifically specific heat. So
What does that mean?
So can you help me understand what specific heat is?
Okay, so specific heat is the amount of energy, thermal energy, it takes to raise 1 gram of matter 1 degree Celsius. Okay?
Okay. So that's specifically the specific amount of heat that's specifically required for that specific thing.
Right. And different compounds, different types of matter have different specific heats.
Okay.
Okay.
Well, perfect. Well, can we kind of like map out what each of these things is in this equation?
Okay.
Like, what is Q?
So
for
Q
me?
is the amount of energy for a given reaction.
Okay, so that's energy, like heat energy, right?
Right.
So
Heat that's released.
Mm-hmm. And then M.
Is the mass of your sample.
Yeah, little m is always mass.
Mm-hmm.
And what about C?
So C is a specific heat value. This is constant for a given type of matter. So you'll be given a table with these values. You'll look up what you have. So if you have water, H2O, you'll find the specific heat of water and plug it into your equation.
Okay, so that's just the specific heat of whatever substance we're talking about.
Right.
And then a delta T here. So delta means change. I know that, right?
Yep, so change in temperature. So it'll be final minus initial.
Change in temp. Okay, cool. Because this whole thing right here is one thing, change in
Right.
temperature. All right, well, let's go through and see if we can't solve some problems, shall we?
Okay.
I think we got one really good example that we want to do, and I'm going to get my pens set. Okay.
Okay.
So
So-
what do we have in this problem?
If we're going to, we have copper, a copper
Okay.
sample, and we're going to heat it from 25 degrees Celsius to 125 degrees Celsius.
Copper heat from, what is it, 25
degrees.
25 degrees Celsius to 125 degrees Celsius.
Okay, and the mass of our sample is 0.020 kilograms.
Okay, mass of copper equals 0.02 kilograms.
Okay, and the specific heat of copper, which we would look up in our table,
The copper
CP,
CP, specific heat,
is 0.385
0.385
joules
Uh-huh.
over grams degrees Celsius.
Okay, so we're heating it from 25 to 125. That's our delta T.
Mhm.
We got the mass is 0.02 kilograms, and the specific heat of the copper is 0.385 joules per gram degree Celsius.
Right,
I already noticed a problem.
grams.
The specific heat has grams in it. The
Mhm.
mass of the copper is in kilograms. We need to change those kilograms to grams, right?
Right.
So we need to do what? We need to
Convert it.
multiply by 1,000.
Right.
Right? So I'm going to multiply this by 1,000, and that gives me 20 grams.
Yep.
Right? All right, so my equation I'm going to use now, remember, is that Q equals MC delta T. So we want to know how much heat that took, right? So the Q is going to be equal to the mass, which is 20 grams,
Mhm.
times the specific heat right here. And remember, you could find that on a chart. It will be given to you in a problem, or you'll be asked to calculate it if given everything else. Joules per gram degrees Celsius. And what's the change in temperature? How do I figure
Be
that out?
125 minus 25
Yeah,
degrees
so the
Celsius.
final temperature right here minus the initial. So
Which would end up being 100.
125 minus 25. And yeah, that would end up being 100.
Mhm.
So
Multiply.
we'll just call that 100 then. So multiply everything together, and the Q ends up being,
770 joules.
and it's just joules. How do I know it's just joules? Well, look right here.
All your units have to be the same.
All units got to be the same.
And
So
that's how much heat was absorbed when this sample of copper was heated. So that's
Yes.
how much energy had to be put in, how much heat had to be put in to raise it 100 degrees.
okay. Well, that seems pretty easy. Just really, guys, make sure that you're looking at your units. You got to have grams for your mass. You got to have degrees Celsius for temperature. We don't have to do Kelvin. And you have to have your Q will be in joules.
Yep.
And if you ever get confused as to which one you should have, always just look at your units here for that specific heat. That'll give you a good reminder.
Yep.